I think I'm ready. So there was a handout on Monday. Practice. So where the extras went. They're not in my folder. But today is a review day, so we can get some more copies printed if anybody needs them. How many people need copies of the practice test? 2, 3. Okay. Yeah. Didn't you get that on? Weren't you here on Wednesday? You don't have it with you? Did you do it? Did you have any questions? Okay. Well, anyway, yeah, so today's a day for questions. There was the quiz 2. I've got about a third of the way grading it, but I have solutions posted. And the link for solutions to homework and tests still has that. And I've also activated solutions to labs 7 and 8. So that's available. These are the lab 8 solutions. Oh, there's actually, someone did an iterative max value. Jacob did that. That was optional. I don't know if I took that off yet or not, but Daniel actually did one to show the path, which is kind of cool. Yeah, this is last year. Daniel's really talented, and yeah, you might think how you would modify it to be able to show the path. It's kind of a cool thing. Yeah, anyway, that's lab 8. There's also lab 7 posted. Okay, and then I have solutions to quiz 2, just hot off the press. These are, there could be some errors in there. If you see anything, let me know. I threw them together really fast. But this is the, there are a bunch of different ones. There was remove ends for an array list, remove ends for a linked list. There was clear to n for an array list and clear to n for a linked list. And then there was these compared to and actually I guess I was a little too indirect because of the answers that I saw were not very similar to what I was looking for. When I ask you to write, make the modifications so that this class can be sorted, objects of the class can be sorted, that means you should write the compare to method for the class. You don't have to write a sort method for the class. Some people did. And the compare to method allows you to use arrays.sort, right? Because it requires your objects to be comparable so it can actually sort them. So this seems to be unusually confusing for people how to actually write these compare to methods. Probably because I went a little bit overboard in my demonstration and gave you all these kind of options, which you don't really need if you're doing something pretty simple. So one thing you do to make a class be sortable, you have to make it implement the comparable interface. And you should include the comparable interface as an import. And then what you would do is, so the winner was a class that has a name and an amount. And it was asking you to basically compare winners by name, and then if the names are the same, compare them by the amount that they won, so that you could actually have the amount listed in ascending order if a lot of people have the same name. If it's a big sweepstakes or something, some people with the same name, you can count for that. Anyway, this kind of thing is basically if you can, first of all, the name is a string, So you can use the compare to method for the string objects to see if those are the same. And if it's the same, they're going to be giving you, the compare to method will give you a 0. If that's the case, you can do a fancy formula on returning the amount, but you know, I don't expect you to have to know this. You can also check to see if this dot amount is greater than or less than other dot amount, then return -1, else if this dot amount is equal to other dot amount, return 0, else return -1. You can do something like that, which you'll see below in some of the other examples. And then if the names aren't the same, you just return the comparison of the two names, either positive or negative value. Remember the compare to method, what is the compare to method returning? An integer. But what kind of integer? What does that integer represent? Whether it's bigger than, smaller than, or equal to, right? How does the compare to method indicate that the object is, the host object is smaller than the argument? -1 or any negative value is going to mean that the host is smaller than the argument, right? Any positive value means the host is larger than the argument, right? So that you just have to return a positive or negative or 0 value. It doesn't have to be any particular number, and then we put that in comparisons to you know, to in logic and stuff to see what the situation is. You don't have to have the compare type, and all that stuff was a fancy way. We were playing around being able to, you know, change the sorting order. Like maybe one time you want to sort it by name, another time you want to sort it by value. I don't need that in this case because we just wanted to sort by name unless the names are the same, and then we'll sort by value. So there's really just one option for compare to. You don't need all those different options. A lot of people threw that in way more than I need. Thinking too much on that. So that's the kind of thing for the winter class. What about the money class? If you got that problem, you had to deal with money, which was split up into integer dollars and integer cents. Well, that's a case where they're both integers. One thing you cannot do is say if this dot dollars compared to other dot dollars equals 0. Why can't you do that? They're primitives, right? So you know, doing something like that is illegal, right? Because you don't have those methods for primitives, right? This does not exist for integers, right? So you can't actually say that. Nor does it exist for char, for the Scrabble tile. So if you're dealing with primitives, you have to do the straightforward if this is equal, you know, or less than or greater than. And you can just sort of stack them up like this. Now, the first one is, is checking to see if dollars are the same. So if you have the same amount of dollars, you could then just check to see if the cents are different, right? If this cents is less than other cents, then return -. So if the dollars are the same, then you got to check the cents, right? There's no other option. If the dollars are the same, you have to check the cents. Otherwise, just compare the dollars, and that's what this one is doing. And then there was a Scrabble tile class. If you want to just sort them by the letter only, you would say something like, you know, if this dot letter is greater than other dot letter, you could return 1. If this dot letter is less than other, return -1. Otherwise, return 0. Again, chars don't have compare to methods either, so you can't say this dot letter dot compared to other dot letters allowed when you have char, because char is a primitive data type. It's kind of like an integer, but it's interpreted as a symbol. Okay, and then there was, what if you had to sort them by value and then by letter? Okay, well, to sort by value and then by letter, you would first check the values. A lot of Scrabble tiles have the same value. If they're the same, then you can do that whole thing with checking the letters. Otherwise, you can return The subtraction of them, that's another way to do it. If they're both integers, you can say this dot value minus other dot value. I think this is really confusing for people, right? How many people find compare to methods confusing? Okay. The wording of the question itself was more confusing. Yeah, then you ran out of time. Yeah, I noticed some people ran out of time because it had like partially completed sentences. Yeah, so, but I think there is an aspect of, I want you to know why you're writing a compare to method, right? So why do you write a compare to method? So you can sort things, right? That's kind of the main reason why you have a compare to method. So if you need to sort your objects, you have to write a compare to method. I can think of a number of things. I just don't know, given the time we have, how much to spend on compare to. I think it's important, but I think a lot of people are, you know, I mean, I can sort of draw pictures and kind of diagram this if it would sort of help you understand the, you know, why it's this way. Sean, you're shaking your head, but not everyone is Sean. So does anybody want to see more or get more support on how compare to is actually, do these make sense? You can pull these up on the solutions yourself, and you could ask me to explain something. I'd rather not just talk and have people eyes glaze over, but if you have a specific, if you can articulate a question, that's a really good thing, and then I can answer it. This is sort of a good time for you to start thinking about what you need to know, what you're unclear on. And it could be this, it could be the first questions where you had to write these methods to modify a list in some way. Or it could be recursion, or it could be big O. Yeah, Vincent? Compare to methods are mainly used when you are sorting. That is the question. And was there another part to that? Yeah, so you can use the arrays class to sort it. Yep. Yeah, if you're going to write your own homebrew sorting operation that sorts arrays of tiles, you don't have to implement comparable, because you could conceivably get in and mess with the stuff, you know, directly. But it's a convenience to be able to use utilities that Java has provided, right? So actually, I think as I was looking at the question, what I should have said is, you want to actually, you know, make this array and use arrays.sort on this array and make it sort. Would that help? And when you read that, would you say, oh yeah, I need to make I already got a sort, I don't need to write the sort, I need to write the compare to method. That's kind of the connection that I would like people to make, the reason why we're writing that sort stuff. And you wrote your own sorting algorithm, so you know kind of why compare to is useful. Okay. Yeah, questions? Any questions? You can even, you know, look up the arrays.sort. In Java, and it will, you know, when you actually look at it, of course, there's a lot of different ones, but it will actually say, like, when you look at the ones that take objects, all elements must implement the comparable interface. So that's just something to think about. And what else is confusing? I actually did some people checked into the online office hours last night, And I know a lot of people have issues with recursion, and I was doing some traces from the drills, I think, and also the practice test that people had asked about. And I can do more of these or explain these in greater detail if people would like. This is the display digits program. I think that's in the drill exercise, where you had to write that missing statement. And just to kind of explain how that works, you can think about this. This is calling display digits if it's bigger, if the number is bigger than 10, it's calling display digits of n over 10 using integer division and chopping the number down until it gets to a number that's smaller than 10, and then it just displays that number. John?
So 2 questions I have from assessment grade.
Mm-hmm.
Questions 8 and 2 parts from 15.
Sure. Question
8, tracing out the
Yeah, again, I'm giving you these drills to get people comfortable with the idea of recursion. There are some really challenging mental loops you have to go through for recursion. Did you say starting with 8 or starting with 6? Yeah, 8 references 6. So you got 6, okay?
Yeah.
But we could kind of. I think I was starting this last night. So when you see a method like this and you're asked to trace it, you know, it's really a question of just sort of stepping through the process that it's presenting to you, right? So you are given an array and it has 9876 in it, and I'm trying to build up the your understanding of it slowly. So starting with a kind of a relatively simple case, displaying array of 2, 3 is going to check to see, first it prints the array of first, and since first is the number 2, right, the 2 gets copied in, and actually did a nice markup. What if I could do that again? So we're passing, right, the 2 is getting copied into first, and the 3 is getting copied into last. And we are going to print, initially, we're just going to print out array of first, and that prints out array of 2, which is 7, right? That number right there. Then we check to see if first is less than last. So when we're checking to see if first is less than last, what we're really checking to see is if 2 is less than 3. And the answer to that is true, right? 2 is less than 3. So we have to display array of first plus 1 last and display array of first plus 1 last, right? So this is actually pretty complicated, but when we display array, so we're going to call display array. So this is the case, we're going to say display array of 3, 3, and then we can't actually do the second display array 3, 3 until we come back from the first one, right? So we have to jump into another level down. Okay, so we jump in another level down, and in this level, what do? In this level, both first and last are 3. So what happens in this level? Well, the first thing it does, it says print array of first. In this case, first is what? It's 3. So we print the first data of 3 or array of 3. So this is going to print data of 3, which is going to be the 6. And then first less than last is really checking to see if 3 is less than 3. In this case, that's false. So we just return. And when we return, we go back and we step out of one level of indentation, right? That means we return to this level. We return to this level of indentation. So we're back in the call of display array of 2, 3, right? It's really hard to keep track of where you are, but the indentation can kind of help, right? If we finished processing the display array of 3, 3, we're back at this level, the blue level, and the next thing we have to do is what? We're back, in other words, we come back from processing this guy, and the next thing we have to do is process it again, right? So that's a redundancy, it's a mistake or whatever. So we have to actually do display array of 3, 3 again. And well, that's going to do exactly the same thing as what we just did. We're going to print 6 again, and then return. And when we return that time, we're finished because we did that whole thing. We're finished with the display array of data of 2, 3. Right? That's 6. Okay, is that kind of helping? I don't know. Quiet group. Is this blowing people away? Back up and rewind and do it again so I can ask questions. Anybody? Well, I think we have to do 7 first, don't we? Doesn't 8 rely on 7? Well, what's your question on 8?
I got lost.
Well, that's the point. That's why I built it up, right? Because when you do 7, right, data of 1, 3 is going to call data of 2, 3 a couple times, right? And you know the answer to that already, right? That's the beauty. Well, if you know the answer to 7, you can use that in the answer to 8. Because data, display array of data 0, 3 is going to call display array of data 1, 3 a couple times.
Right. I get that. I just felt hoping that clear, simple way of getting it out.
Well, it's just doing what I mean. The best way I can does this seem clear and simple to you? This approach?
No.
That seems complicated. How did you do it? Okay. This is you think this is, so you actually agree that this is clear, right? I think this is the clearest way to do it. To like every time you have another recursive call, indent further, because you're going deeper into the runtime stack. I mean, you can also build up those stacks and stuff the way we also did it in lab. That's. But I think this kind of lays it all out. You keep indenting every time you go another level deeper, and then so this is your answer to display array of data of 2, 3. Now you can use this in another problem. So like this one is going to ask us to do display array of data 1, 3. So all we have to do is, I think I'm going to just go like that and call display array of data 1 and 3. And now in this case, it's going to print data of 1, right, which is the 8. And then it's going to check to see if 1 is less than 3, right? If first is less than last. If that's the case, yes, it is. Then we're going to actually invoke display array of data 2, 3, right? And we already know the answer to that. That's why I kind of built it up that way. Data of 2, 3 is just going to print out 766. But when we return from that, we're finished with data array, display array of data 2, 3. So we come back to display array of data 1, 3, and we got to do that one more time again, right? We have to repeat that whole block again, right? So you could just copy and paste this whole block. This is actually the clearest I can think of to kind of express how this is actually working. It's going to print out 766, 766. No, it's going to print out 8, 766, 766, right? So summarizing, display array of data 1, 3 prints out 8, 766. Let me just 766, 766, right? So then display, you can kind of just lump those together, right? So display, so therefore, you should be able to see that pattern, right? It's the first number followed by 2 inches of the second number, each of those followed by 2 inches of the third, and so on, right? So then therefore, you should be able to look for the pattern, right? Display array of data 0, 3 is going to start off with 9, and then, oops, not that. Display array of data 0, 3 is gonna, I'm just gonna copy this thing. It's just gonna say 9 and then 2 copies of that. And that should be the answer.
So for question 12,
Mm-hmm.
if we look at that, is that it says how many times will the method merge be called if an array contains these values? Is it basically asking how many times is there the indentation? How many times are we indenting? Is it the previous form of tracing?
I haven't seen this one in a while, and so merge sort is implemented with a sort method that calls merge, right? And so the sort method is actually recursive, and it's calling itself again, calling itself twice for every level, and then calling a merge from the 2 halves together. How many times will the method merge be called if an array A contains the values 1, 2, 3, 4, 5, 6, 7, 8 values and sort of A 0, 7 is all? Well, I would do it kind of like I just showed you with just indenting. I just think it's the easiest thing to universalize this whole thing. And it's not even asking us to do the merge, but how many times is it actually called? So what I would do is I would just sort of I would just work my way through all these calls and just sort of see what's happening here, right? So in other words, so I'm initially calling sort of A from 0 to 7, right? So this is going to, it's checking to see if n1 equals n2, 0 equals 7 is false. 7 equals 1 is false, right? So we're going to compute m equals 7 over 2, right, equals 3. And then we're going to call sort of A 0, 3, right? And what happens when we do that? We indent and go into that, right? We got to do that before we come out. When we come out, we're going to have to do it. Now, if you want to, you could sort of make a space, but we're not going to get to sort of A 4 and 7 until we come back from sort of A 0, 3. So you can indent and do that. Sort of A 0, 3 is going to check to see if 0 equals 3. No. Does 3 equal 1? No. So we're going to calculate m as 0 plus 3 over 2, so that's going to equal 1. And we're going to call sort of A0, 1. And we're going to go in there, and when we come back, we're going to call sort of A2, 3. Now we're getting to the point where something is going to happen with the merge, I think, right? So sort of A0, 1 is going to check to see if 0 equals 1. No. But then we're going to see, well, does 1 equal 1? Because 0 plus 1 is 1. True. So then we're going to actually do this swap and return after a swap, which we're not interested in, but that's what's going to happen. And when we do that, we're going to then do sort of A, 2, and 3. And again, we're going to check does 2 equal 3. No, but does 3 equal 3? Yes. So we're going to do another thing. And we'll do another swap return. Now this is getting a little tedious, but I think it's, it's log n and log, so it's not going to happen too many times is the point, right? So when we finish from that, we finish these two deeper calls, then we're going to do finally a merge. So we're going to do one merge right here. And that's at the same level of sort of A03. So sort of A03 is going to do one merge. And you could assume probably that after we do sort of A03, we got to do sort of, so that finishes, and then we got to do sort of A47, right? I think I already have that down there. Yeah, it's right there. And I think you can kind of see that sort of A47 is going to do one merge as well, right? It's going to do about the same thing. And it's going to do like one merge. And then finally, we finish those two, we're going to do another merge, right? So how many times was merge called? 3 times. Is that the answer? Yeah. So that's how you have to. So this actually, what I'm hoping that, I know this is actually really challenging, but I think if you can pull the hood off of recursion and just sort of follow the steps, is sort of what these problems are asking you to do, it sort of demystifies it. Recursion is a very mysterious thing when it all happens quickly and you don't really understand. But when you can actually follow the recursion around, going through all those calls and back up again, it makes it a lot easier to comprehend. Marco. Will you be allowed notes? Will you be allowed notes? I think so. What does it say? Does it say anything about notes? Yeah. What did it say last time? Let's go see what the notes say. Okay. The best notes are the notes you carry embedded in your nervous system because you've been doing the work, and they come out without you having to ask them or look them up. But can't have solutions to the practice test or assignment. I guess I'm trying to figure out a way, because I don't like the people that just like microfiche everything. You get this tiny microscopic thing. I think stepping through a few of these things, I mean, maybe it's best to just do these so that you don't have to write this down, right? If you can just do this, because having this kind of thing on your cheat sheet isn't going to really help you if you don't understand why we did it this way, right? It's really getting that stuff ironed out. And if you have any questions about the concept, the process that I just showed you, that's what you want to sort of work out. So So we'll stick with that, I guess. I can't think of any better way to express that. But yeah, just practice is the best way. Questions? Any other questions? Yeah, Michael?
Are you going to organize the exam like mostly like sorting like these things here, or is there a lot of those and kind of stuff that work?
Well, I think the practice is a reasonably good approximation. There's big O. One thing I'm going to change about the big O is I don't like it because it was like 10 points for these questions, and then, you know, I don't really know how to, if you screw that up, it seems like a lot of loss. So I think I'm going to have more big O questions that are going to be worth fewer points. So if you can kind of get most of them and get lucky on some of them, you might do better. But yeah, you should understand how to trace a recursive method, Paul. There's two here. One of them's working with integers. One of them's working with strings. Those should make sense to you. Writing a recursive method is pretty important. Understanding how the sorting algorithms work. I mean, I don't know. Can't tell you what's going to be on or what's not, but writing a compare to method is pretty important. And now that you've done enough of these, I think it hopefully will make sort of sense. This is a question a lot of people would miss, but you know, in addition to writing, yeah, this actually is not worded very well either. I guess it's so that arrays.sort could actually sort them. Taking a problem statement and doing a before and after sketch, a memory map of how this should look before and after, because if you can't draw the data structure that you're working on, then you know, that's going to be hard to solve anything. So I think these are reasonable. This is a pretty reasonable picture of what the exam's going to look like. Here is a method that you have to write for linked list. I mean, there's hints here. If you can figure out your own way, you don't have to follow these hints, but I'm kind of helping people kind of get through this. Yeah, so that's basically what you're going to be asked, pretty similar to what you're going to be asked to do. Is there anything I missed? I think it covers, you know, covers big O, it covers recursion, reading and writing recursive methods, reading and writing methods that work with lists. Yeah, that's I think I don't really worry too much about stack and queue implementations because they're kind of a subset of lists. So I kind of just go mainly for lists. You know, you should be comfortable with array lists and linked lists. You can focus on those if you want. Okay.
Just so you know, the link for the sorting innovation slash code chapter in lab 8 is approximately. It goes to page 9.
I didn't know there was one in lab 8. There is one. Oh.
There's one in lab 7 as well.
Oh, wait, lab 8 was on recursion. Yeah, so I think I noticed that had changed and I had to fix it in lab 7. I didn't know there was one in lab 8. Yeah, they moved the site a little bit. It's still on visualgo.net, I think. Was it visualgo.net in lab 8 too? Yeah, they restructured, occasionally sites will restructure their website, that just really drives me crazy. Yeah, that's what happened, right? They became international, I guess. Oops, that's not it. So they're starting you off with a tutorial, which you can kind of skip, I guess, at a certain point. But yeah, it's interesting how they changed. Practice test. All right, let me get up there. Oh, I do? Oh, right there. Good. Yeah.
3B,
Mm-hmm.
or doing the comparison method, we need to say imports comparable, or say the implement comparable.
I mean, technically, yes, you do. I was kind of a question just to make sure people. I really wanted to make sure people said implements comparable of song, too, because that's what you need to use the arrays.sort method. I mean, really, the question should be worded to say, will allow an array of song to be sorted with arrays.sort. Did everybody like the Golnish and James Big book of Big O? Did that help clarify things for Big O or make it worse?
It's like a part B, that answer to you, I answered that a couple times, and it kind of confused me a little bit.
Answer D? I'm sorry.
Yeah. When do you know, is that like the longest wait time for this log n and q minus log 2 to n?
No, it's not the longest. In fact, the order is pretty much alphabetical in terms of increasing complexity. N to the n, it's hard to even conceive that. Let's see. No, I don't think any of these answers are n to the n. We did get, H is a traveling salesman problem, is n factorial. N to the n would be, yeah, I can't think of that. Maybe that's one of those things in the dictionary example that there was on Stack Overflow.
Helps you keep your progress without losing it?
No, so factorial is, You know, 5 factorial is 5 times 4 times 3 times 2 times 1. It kind of covers when you're doing a lot of different permutations. The traveling salesman problem says, suppose the traveling salesman has to visit 4 cities. You know, what's the shortest distance, overall distance to visit those 4 cities? It depends on how they're actually arranged in space, right? You know, how long it takes to drive from A to B or B to A, or any you could visit them in any order that you want. This is sort of a salesman. If you were a salesman, you'd be running into this problem all the time. And that's why a couple of years ago, a student was doing a solution for the final project using the traveling salesman problem for genetic algorithms, so that his brother, who's a salesman, could find a more optimal way. It's time consuming if you go the wrong way to a bunch of different cities. So the possible options to visit 4 cities would be, you could start with city A, and then you could go B, C, D. Well, or you could go B, D, C, or you could go A, C, B, D, or you could go A, C, D, B, or you could go A, D, C, B, or you could go A, D, B, C. That's just the cities, that's just starting at A. These are all the options of permutations of starting with A. And then I don't think there's any redundancies in there. But then when you start with B, you have sort of one less option because, no, I don't think so. But anyway, it's listing all the permutations of ways of visiting cities. That's what the traveling salesman problem does. Yeah. Yeah, it's when you have something like permutations. Yeah. So let's think if you just have 3 cities, A, B, C. You could go A, B, C. You could go A, C, B. You could go B, C, A. Go B, A, C. Or you could go C, B, A. Or you could go C, A, B. Now the thing is, some of these are going to be the same, right? Because A, B, C is going to be the same distance as C, B, A. So that's not a unique solution, right? In other words, if you're traveling from A to B to C, or if you're going from C to B to A, it's the same distance whether you go backwards or forwards, right? So you kind of have to eliminate some of the redundancies that way. So in that case, and I guess, I don't know, maybe you want to end where you started. So that's A, B, C, A. I don't know. If you did it that way, well, you're not going to have a problem involving n factorial. So these minuses are not negatives. These are actually just separators. It's like a delimiter. Yeah. Yeah. Yeah, question? Like which problems were you having problems with? Yeah, I reworded some of this to make it a little bit clearer, because I think, which one? Kind of blurry trying to figure out which one to choose. I think 14 is the best score. Yeah. So these are conceptual problems, and you have to sort of think about what is the event that controls the repetitions. Arriving at a party is like, okay, that happens once. Shaking hands with everybody at the party is going to happen like on the order of n times, because there's n guests, right? So that's like O of n. If n gets bigger, you're going to have twice as big, twice as many handshakes. If everyone shakes hands with everybody else at the party, that should sort of seem like, if you're going to write some code to do that, it would kind of be like a nested loop, wouldn't it? So that everybody shakes hands with everybody else. And that would be probably one of those things where, let's see, well, let's just simplify it. For I equals 1 to n, right? For j, I think it's like one of those for j equals 1 to I. That will avoid redundancies, right? So I, j, so you're going to have like, 1, 1. And then you're going to have 2, 1. And then 2, 2. So this is basically shaking hands with yourself. I guess you would probably skip that. Maybe, if if I equals j, you would sort of skip, right? Otherwise, it's sort of like I meet j,
Right.
and implying that there is a handshake, right? So if I is j, we skip that, all right? Skip that. So, or just do 1, 1, skip. But 2, 1 is going to be a shake, is where 2 meets 1. 2 meets 2 is going to be a skip because they're not going to shake hands with themselves. But then you're going to have 3, 1. That's going to be a shake, right? 3, 2 is going to be a shake. 3, 3 is going to be a skip. Maybe we should just change the loop so it just says 1 to I minus 1, right? That would be a little bit easier. Then we wouldn't have to do any of those skips. So for 1, this is a new contact, right? 4, 2. So in general, it's going to be, this is sort of like Gauss's thing. It's going to be n times n over n times n minus 1 over 2, something like that, which is order of n squared. Handshake's going to take place at a party like that, right? So just actually completing it when there's, so if n equals 2, there's only going to be 1 shake, right? If n equals 3, you're going to have 3 handshakes. If n equals 4, you're going to have, you can sort of imagine, well, you're going to have another shake there. So you're going to have 1, 2, 3, 4, 5, 6 handshakes. If n equals 5, you're going to have another 4. You're going to have 10 handshakes. As you kind of extrapolate this, you're adding on 1 minus the next number, right? So 15 handshakes. So this is kind of like, this is sort of like the sum of the digits from 1 to n minus 1, which is, it's like n minus 1 times n minus 2 over 2. So that would give you an n squared kind of behavior. Now, if everyone shakes hands Oh yeah, that's the n squared one. 16 is you announce the pizza has arrived. That's sort of one event. 17 is you walk up to each person and read the guest list to them. This is a slight modification of what I used to have there. But the idea is you're walking up to every person and reading the guest list to them. So you're reading, n names, n minus 1 times. So that's sort of an n squared kind of process. Everyone walks up to everyone else and reads the guest list to them. That's going to be an n cubed process. Maybe I will do that dictionary, the ill-fated dictionary company that had a robot try to sort out everything. Totally screwed it up. Yeah, Mark?
Are you going to be like having like the same questions for sorting, like knowing the difference on how it would result out, depending on what kind of sorting method you use?
Sorry. How are you going to be able to figure out, in other words, is there going to be a problem like 3A on the test? There might be. Did you have a problem with that? Mm-hmm. Conceptually, how do those work? Marco, question? Sure. What do you know about how selection sort works? Conceptually, how does selection sort work? So it finds the smallest in the array and swaps into position, right? At every step, it's finding the smallest in the array in the remaining part of the array and swapping into position. That's how selection sort works. So if our array were these items, let's just start with the numbers, 4, 15, 8, 3, 28, 21. After the first pass, the smallest number is going to be put into its position, right? So the first pass is going to find the 3 as the smallest number, and it's going to swap that with the 4. So you're going to have 3, 15, 8, 4, 28, 21. After the second pass, the next smallest is going to be the 4, right? So 3, 4, 8, 15, 28, 21. We're swapping the next smallest one with the item that's sitting at its location. That's sitting at the place where it should be. So selection sort is selecting the next one in line to be moved into its position, right? The next pass is going to find the 8 is already in its location, so there's no need to do any swapping. The next pass has got the 15 is in its location, and the next pass is going to swap the 21 with the 28, and then it's finished. Well, how does bubble sort work? Yeah, any 2 adjacent items, it swaps any 2 adjacent items. That are out of order. So starting with that, you know, you go through and, well, 4 and 15, those are actually okay. But 15 and 8 are out of order, so we have to swap the 8 with the 15. And then, well, the 15 and the 3 are out of order, so we have to swap the 3 and the 15. 28 is okay, but 28 and 21 are out of order, so we got to do something like that. So that's one pass of the bubble sort. Next pass, you know, the 4 is okay with the 8, but then the 8 and the 3 is out of order, so you got to swap those two. The 8 and the 15 are okay, but then the 15 and the 21 are okay, and so is the 28. So after 2 passes, it's almost sorted. Mm-hmm. Insertion sort is well, insertion sort starts with the second item, and it tries to insert the second item into a list that begins with the first item. And when it's finished, after the it doesn't really have to do anything with our original data set here, because the 15 is going to get inserted right after the 4. In the second pass, it's going to take the 8 and try to insert it in this list that begins with 4 and 15, and it's going to have to put it in the middle. So the first pass is no change. And the second pass is just putting the 8 between the 15 and the 4. Well, in this particular case, the first pass doesn't change anything, but that's not always going to be the case. If you know, if it started with a different set of numbers, it would have to switch the order as well. Well, it's like you have a deck of cards or a hand of cards, right? And you're trying to organize them in increasing order. The easiest way, because it's easy to insert cards in a hand, slide them between each other. You consider the first card, and then you look at whether the second card needs to go to the left or right of it. In this case, the second card did not have to go to the left of it, so there was no change. But if the second card happened to be a 1, then it would have to move the 1 in front of the 4. Yeah, because the second number was bigger than the first number. Yeah. Mm-hmm. Yeah. Yeah, Mark?
You want to put or merge sort instead, like mixing it up.
Quick and merge sort, those are actually fairly complicated. An interesting idea. It'd be kind of fun to do like quick sort on an array that only had like 4 items or something. You should be able to do that. Right? If I gave you the code for quick sort, you should be able to trace it. Who still needs a printout? Anyone else still want a printout? I guess we can print a few copies here with the local printer. You good? Okay.